All right, good morning. Welcome to Activity for Processing 2.10. This is designed for you to watch before you actually attempt Cooldown 10. This is going to be a great way for you to see two examples today, which will mirror or look identical to the cooldown. So if you feel confident after walking out of this that you can hop into the cooldown, go for it. But after this, if you are still confused, you definitely want to visit me so that we can get ready for the cooldown. So walking away confused from this is a good indicator that you are not ready to take the cooldown, okay? So in order to do this well, here's what you want to be able to have in front of you. You want to have your notebook in front of you, a calculator in front of you, and obviously something to write with. If you have any other devices that are possibly going to distract you, definitely want to have those. This is not a video you watch in the background. This is your attention for the next whatever moment the length of the video is, right? So you should not be multitasking during this time. Next, in your notebook, here's your title, because you're going to keep these organized in your notebook. So this will be lesson 10. Next time we see activity for processing 2.11, you're going to skip a few lines and then create a new section in your notes for activity for processing 2.11. The same for 2.12 and so on and so forth. So you want to have your spiral notebook set up so that every single lesson is in order. So whenever we go back and we're taking a quiz, because those will be open notes, you can just go back to your notes and open it up. So if we have a question from this section, you just go back in your spiral notebook and be like, all right, what did he say about that? Where are the examples? All right, without further ado, before I actually get to example one, there's one thing that maybe was not covered in the previous video that we need to refresh, and that's degrees. So we talked about degree one. That's like linear. Degree 2 was parabolic. Degree 3 was cubic, like a snake. And then degree 4, it's kind of like a degree 2. It's parabolic, but it has like a little bit of a wave to it. Okay, I'll show you 5. And then 6. Okay, so I don't think it's covered here in this particular part of the lesson, but you will notice that 2, 4, and 6 look very similar. These are called even because they're even numbers. So these are even functions, even powered functions. 2, 4, and 6. Here, let me put a little check here, here, and here. You will notice that they look similar, and that's for a reason, which we'll speak on next time. And then you'll notice odd degreed functions, this one, and this one, 1, 3, and 5. Those are odd numbers. They kind of have like the arrows opposing each other. So you will see this on the practice problems, and you'll also see this on the cooldown where it's going to say, hey, sketch a degree 4 function. So this is what it would look like here, a degree 4 function. Now, I'm not telling you that's the answer, but you need to know that your final answer needs to have some kind of curve. Now, is it facing upward? Is it facing downward? Is it linear here and curved there? Or is it curved here and linear there? You know, we're going to go into that in a moment. But just a refresher on degrees in case you forgot. Okay, so our first example is going to have us look at a degree 3. It's also going to have zeros at the following locations on the x-axis. It's going to have it at x equals -3, at 3, and at 8. And then here's the end behavior. Okay, follow me here, because the book is going to write it in a sentence form, but since you're going to go into trigonometry next year, you're going to see it written using symbol notation. It's actually going to be our last unit this semester, actually. So here we go. And I know this is something that we just saw, and for a lot of us, it's fresh, it's new, and maybe not mastered last year. So here, definitely pay attention to this part if you're like, this is the first time I've seen end behavior and I don't know what he's talking about. So all graphs go to the right and to the left, no matter what. So these two will never change, okay? So all graphs go to the right, all graphs go to the left. Now, how much do they go to the left and the right? We don't know, but that doesn't matter. We just know they do. Each one goes different amounts. Some of them go a little more to the left, a little more to the right. Now these two are what's going to change on the quiz, on the questions. These are the two things they always change. For this example, I'm going to make them both. Well, let's make this one positive, this one negative. It'll keep things spicy here. Okay, so this is the end behavior of our graph. Let me read it out to you because the book's going to say it like this. As x gets larger and larger in the positive direction, y gets larger and larger in the positive direction. As x gets larger and larger in the negative direction, y will get larger and larger in the negative direction. Now, what the heck does that mean when you're sketching a graph? Let's jump in. Okay, I think I'm going to make a little more space here. Zeros were at -3, 3, and 8. Okay. Okay. So now I'm going to think out loud so you, my students, my audience can know what is going through my brain when I read these 3 different characteristics and how I'm going to put them all together to create this graph. So degree 3, I already know it's cubic. Let me switch into blue. Okay, so that's cubic. Now, is it cubic like this? Or is it cubic like this? I don't know, but it's cubic for sure. It's a snake. These are the only 2 possibilities I have for that. Zeros. Okay, so I remember this one. So all I have to do is switch the signs on each of them, and that's going to give me my 0. So if I switch -3 into +3, I apologize, I didn't label my XY axis with X and Y to let my students know that this is an X and Y axis, and we're going to draw a graph on top of it using these characteristics. Sorry about that. Okay, so I just got this one. +3, change it into -3. And then +8, let's switch it into -8. So it's going to be over here. Check. Okay. Now I'm going to go back into red to show my end behavior. So as x gets larger and larger, ooh, let me tell you guys this. When you read these two, the x's never go together because left and right in the same sentence would lead you nowhere because then you don't have up and down. So you always read this together, the x and y. Think of it like as an xy coordinate pair. Okay, it's never this x. It's never this y. Those things, no, don't do that. So you always read it like this. There needs to be an x and a y. There needs to be an x and a y when you're talking about directions. And you will always have one direction here and another direction over here. So the 2 directions will give you 2 end behaviors. There's 2 end behaviors on this graph. There's 2 end behaviors on this graph. Now, by reading this, we're going to know which one of these 2 graphs we need to do because one of them is going larger and larger in the x direction and larger in the positive. Let me say that again. I apologize. Larger and larger in the negative direction. So it's going left. And this one's going larger and larger in the y direction. It's going up. This one's getting larger and larger in the positive direction for the x, and this one's getting larger and larger in the negative direction for the y. In a moment, I'm starting to see right now, it'll be useful after this example to kind of like explore this right here in a moment. Just bear with me a moment here. Okay, so let me go specifically into this one here. As x gets larger and larger in the positive direction, y gets larger and larger in the positive direction. So this is right, and this is up. So right, up. You will notice that I'm going to draw my end behavior after the point, after the 0, because if I put it here, imagine I drew a graph here. This point's not going to be on the graph. So you got to make sure that your end behavior is always after the last 0. So you can assume safely here the next end behavior needs to be somewhere over here to the left of the -8. Okay, all right. So this one, as x gets larger and larger in the negative direction, y gets larger and larger in the negative direction. So as this goes left, this goes down. So left and down, left and down, left and down, left and down. All right, cool. So now I'm gonna finish graphing my graph. Okay, there we go. Okay, that makes sense. So let me make sure I have everything I need here. So I have zeros at -3, +3, and at -8. Good. My degree is 3. It is a snake looking thing where the arrows are pointing in opposite directions. It's an odd powered function. That looks good. Now the end behavior, we just did that. So it's right up. Okay, that's good. And then it's left down, left down, left down. Yeah, that's good. So I like to do that after I finish the actual problem. I want to make sure. Well, let me go back to the question. Did I answer it? All right, I know right now, if you were to pause this video and enter the video right now, I'd be like, what is all this? But, you know, just play it back. It'll go step by step. All right. Let me hop more into this. I think it's going to be useful if I talk about this a little more before I hop into example 2. So some notes, if you will. So if you want to skip a line and put notes, that'd be cool. Okay, so I want to talk about notes, and specifically these notes are a little bit more about end behavior. So, okay, this time I'm going to draw a graph, and it has no, here, and I want to make sure I draw the ends a little more strategically here. There we go. We have no XY axis because I don't want too much stuff going on. I just want to focus on this here, on the end behavior. How is it behaving on this end? How is the graph behaving on this end? Okay, so first of all, I need to tell myself this is going left, down, left, down. This one over here is going right, up. So it's going right, I should write up over here. Okay, now here's the part that I've seen people get confused on, and this always helps, okay? This makes everything kind of click. Okay, so you need to understand Y is up, down, and X is left, right. This has always been true since you started drawing an XY axis, okay? So left, this is as X approaches negative infinity. Negative infinity means you're going to the left on a graph. Here, let me bring this up here. So this is negative infinity. This is positive infinity. That's left, that's right. This is up, that's positive infinity. And this is down, that's negative infinity. Okay, let's go ahead and hop into it. Now let's get into this. Down, that means Y is approaching negative infinity. It's going down. Over here, X approaching positive infinity. Sorry, that's Y. And to the right, you see how I checked down here? I was able to catch that. Y going up, this needed to be Y. And if I'm going right, this is X. Going towards positive infinity. All right, let me fill in this little infographic here. So if X is going to the right, towards positive infinity, if X is going to the left, towards negative infinity, if Y is going towards positive infinity, and if Y is going down, towards negative infinity. What trips my students up is that the arrow is always pointing rightward, but it doesn't say that's where the arrow is going. You read it saying, as Y approaches. So the arrow doesn't mean direction. Does not mean direction. Exclamation point, that's a big deal. Otherwise, all of these would be pointing to the right. No, let's be clear about what it means, ladies and gentlemen. These arrows right here, they mean approaching. And for this specific one, it's approaching. Let me switch to purple. It's approaching negative infinity, which is to the left. All right. Let's hop into example 2 here. Now, I know I can move through all of this because you have the power to pause and play and all that good jazz. Okay. Example 2. So you can skip a note, a space there, and then hop into example 2. Here we're gonna have a degree 3. It is as x approaches positive infinity, as x approaches negative infinity. There you go. Okay. And what else did it want? Degree zeros. Oh, zeros, duh. So this was the first thing we had to know. This was the second thing we had to know. And this is the third thing we need to know is the zeros. This function has zeros at 4 and -4. Okay. So first of all, I don't know if you noticed this, ladies and gentlemen, but the number of zeros here does not match the degree. So like, let's do a degree 3 with 3 zeros. Here, here, here. Degree 3 with 3 zeros, that was easy. But how the heck am I gonna do a degree 3 with only 2 zeros? So I somehow need to only have 2 of these and get a snake, get a degree 3. Huh, that's not looking good. Try something else. Okay, so I know I want this, and I can only have 2 dots. That works. I'm not breaking any rules that were described up here. Watch. It's degree 3 because it is cubic. Good. This is good. That's checked. -4, +4. That's checked. That works. All right, let's see if the end behavior works. Actually, I hope it doesn't because if it works, it's like, oh, you already knew the answer. I'm actually doing this from like, I want to make sure you know that I'm not just scripting this, but actually going through the activity with you. Okay, so as x approaches positive infinity, y approaches negative. Yes, it didn't work. Now we can fix it. This is good. Okay, as x approaches negative infinity, y, perfect. Okay, this was not satisfied, ladies and gentlemen. The end behaviors. This is good, but we need to fix this part. So let's fix that, okay? So I need a snake. I need 2 points. I'm gonna politely erase this to myself because that's how this is all gonna work. You're gonna have to do it like 3 or 5 different times, maybe even 10 different times before you land on the correct answer. So remember how I told you, read these 2 together and then you read the next 2 together of the end behavior. So this is, let me label it right, down. This one's gonna be left, up. Okay, so let me do this one first. Right, down, right, down. So it's like right, down. And this one's gonna be left, up. Okay, I know what it looks like now. The end behaviors and the previous graph I drew, let me know what this body looks like. So I know what the ends look like. I'm gonna put a note on the side so I don't forget it. So the end behavior gave me these ends. So I need to now put this, the body together and the end behaviors together. Okay. +4 and -4. Okay, cool. So if you recall at the very first part of the video, you're all like, okay, you're talking about getting these pieces of the puzzle and putting them together. And this is exactly what I'm talking about. It's like you have to make sure that they fit, and it doesn't always feel right. You're gonna have to go through some errors, but now, like I did on the last problem, we need to check if we satisfied all of our conditions. So I already checked these. I'm gonna start over. I don't care. I wanna make sure I get this correct. All right, so first of all, degree 3, is it cubic? Yes, it is. I have arrows that point in opposite directions. So arrows pointing opposite. Cool. As x gets larger and larger in the positive direction, y gets larger and larger in the negative direction. Okay, so write down, that was check. Okay, so I'm good there. Good there. As x goes left, up. So as x gets larger and larger in the negative direction, y gets larger and larger in the positive direction. Yes and yes. Yes, I did get it. There it is. And then zeros at +4 and -4. Yes. So here I'm going to leave you with this. What would this equation look like to represent the graph? Okay. So this part right here, this is linear. This part here, this is quadratic or parabolic. I'll write both words down. Some people prefer quadratic, but I like both because they're both descriptive of what we should expect on the graph. And all vocabulary is good in my opinion. So let's switch the sign. So you got x plus 4 linear to the first power. X, let's switch the sign of this +4, x minus 4 to the second power because it's quadratic. If you remember, quadratic means degree 2. We did that in the beginning part of the notes. And we can call this y. All right, Sanchez. Wow, amazing. This is linear. That part's quadratic. That means right here it's a line at -4 and at +4 it's quadratic. That's cool. Why is that even relevant? Why do we need to know that? Well, remember I told you it was degree 3? 1 plus 2 is 3. Because if you add the exponents according to the rules we did in the first lesson of the year, where we added exponents when multiplying powers, that shows that a degree 1, when you multiply it times a degree 2, will give you a degree 3 polynomial. And that's what we had. All right, guys, hang in there. I know it's a lot of things, putting these pieces of a puzzle together with information maybe we didn't visit in a while or we haven't seen all together. So without further ado, good luck, rock and roll.